experiment. So what we have is we have two 2-liter bottles and some balloons to start with. So Alexa, do you want to try blowing up that balloon? So obviously it's impossible for the balloon to inflate, and here's why. The balloon won't inflate much the first time because already there's gas particles in there that are taking up all of this space. So what we need to do is we need to make an escape hole so that whenever we blow it, all the air particles can escape, and then there's more room for the balloon.
As long as you plug the hole, the balloon stays inflated. When you take your thumb off the hole, outside air flows back into the bottle as the balloon collapses. Because of the elasticity of the rubber or latex, the balloon shrinks to its size as the air rushes out the top of the bottle. If the particles have more room to move around, they won't exert as much pressure on the walls. They won't bump into things as often. When you increase the volume to the amount of the room, you decrease the pressure inside the space. This law of physics is called Boyle's law. My hypothesis for the experiment is that the bottle without the hole will have too much pressure. When you try to blow it up, it won't work because of us explaining Boyle's law. That would make sense. And with the hole, that as long as the escape hole is open, it should blow up fine, and then when you close it, it should stay blown up.
My hypothesis is that I think that this balloon with the escape hole will inflate larger because there's more space for the balloon to inflate because we don't have all the air taking up a lot of space. I don't think that this one will inflate much because we don't have an escape hole, so where are all these air particles going to go? It's just going to push against the balloon, and the balloon has nowhere to go. So it's just going to stay just like this, basically.
Step 1. Slip the balloon inside the neck of the bottle and stretch the mouth of the balloon over the bottle top. 2. Take a deep breath and try to blow up the balloon inside the bottle. Step 3. Punch a small hole in the side of the bottle close to the base. Step 4. Try to blow up the balloon until the balloon fills most of the bottle. Put finger over the hole and stop blowing. To do our experiment, we're going to be using soda bottles and balloons, and we're going to try 3 different ways to do it. The first way is without the hole. Which obviously does not work.
The second way is with an escape hole.
And the third way is by using the escape hole and sucking out the air to blow up the balloon. Sometimes when you do an experiment, things don't work the first try, so we're going to try it again. And it blew up some, more than without it. My conclusion was 80% right. With this balloon, because of the pressure and no escape hole, it did not blow up at all. On this one with the escape hole, when we blew through here and let the air escape, then plugged it, the balloon blew up bigger than any of the rest. And when we sucked the air out of it, it didn't blow up very much. So my hypothesis is partially right on that one.
In conclusion, for my hypothesis, similar to hers, mine was nearly correct also. This one did not blow up hardly much, if any at all. When we blew it through here, the balloon inflated up to about halfway, maybe to about like a 1 liter mark. So my hypothesis was correct on that. And through the escape hole, it blew up very little. And then we can cut it in the bottom. Okay. Oh, shoot.
Put.
Did you like that?